Hi, this is Kevin from Mathsaurus, and in this video we're going to look at questions 11 to 15 of the Intermediate Maths Challenge from 2022. But I actually don't think you should watch this video because I've put all of these questions and more into a free online course called Get Ready for the Intermediate Maths Challenge. In that course, you can work through all of these problems, you can check the answer, you can watch the video solution, but as well as the video solution, there's also a short video hint before each question that will really help you get into the problem and give you the best chance of solving it for yourself. So I'll put a link to that course in the description below. You can go over there and sign up now, totally free, and there are no ads or distractions like there are on YouTube either. So I do really think that's the best way to prepare for the Intermediate Maths Challenge, but of course if you'd rather watch the solutions here on YouTube, you're also very welcome. Do like the video and subscribe to the channel if you haven't already. It really helps me get this content out there. Otherwise we will get on with the questions now. I think this question is as much about English as it is about maths, but really we need to write down an equation and solve it, and it's just phrased in this slightly old-fashioned way. What number is that whose quarter shall be 9 more than the whole? So let's call that number x, and then its quarter will be a quarter x, or x divided by 4. And it says x divided by 4 is 9 more than the whole, i.e. 9 more than the value of x. So I've got x over 4 is equal to 9 plus x. Let's subtract x over 4 from both sides and subtract 9 from both sides. So I'm going to get minus 9 is x minus a quarter x. So 1 minus a quarter lots of x is just 3 quarters of x. So we can divide by 3 and times by 4 here. So minus 3 is a quarter x, and then x is equal to minus 12, and we get that the answer is E. I know you can do the algebra more quickly than this, and so can I, but I'm just making sure it's very clear here. Another option is that you could actually just check all of the answers and say, well, I can just quarter them and see if they're 9 more than the number we started with, and it doesn't take you very long to check all of those and to find that the answer is E that way as well. So this is a good example of a question where we can use different techniques, and the more techniques you know, the more efficient perhaps you can be in solving this. So we'll look at this in a couple of different ways. So basically though, I've got some similar right-angled triangles, and you can use Pythagoras theorem on those right-angled triangles to work out the missing lengths effectively, right? So I could start here and say, okay, on the first one I've got 2 and 2. Pythagoras theorem says a squared plus b squared is c squared, so I've got 2 squared plus 2 squared here, that's 8. So c here, the hypotenuse, is the square root of 8, and you can also write the square root of 8 as 2 root 2. Okay, so I've got root 8 on this side, and then I've got root 8 on this side, and I apply Pythagoras again. Root 8 squared is 8, plus root 8 squared is another 8. That gives me 16. So the next one is the square root of 16 here, which is 4. And again, I've got another right angle isosceles triangle here. They're all similar. So again, I've got 4 squared is 16 plus 4 squared is 16, and I can get the square root of 32 here if I want to. Although I suppose at that point I don't really need to work out that last one for the purpose of working out the areas, right? So because I can say what's the area of the shape in total. Well, the first triangle, right, we're going to do a half times base times height. On the smallest triangle, that's a half times 2, which is just 2. On the next one up, that's a half times root 8 times root 8, which is 4, half times 8 effectively. And on the last one, it's a half times 4 times 4, which is 8. And then I can just add those together to get the area of the whole shape. 2 plus 4 plus 8 is 14, and so the answer is A. Now there's lots that you can know in advance for this question, in particular knowing that when you've got a right angled isosceles triangle, you might just know that there's a scale factor of root 2 that takes you from one side to the hypotenuse, right? Now the fact that that scale factor exists then also exists in all of the other triangles, right? Root 8 to 4 and then 4 to root 32. But you could also say, well, actually you know that if you've got an area scale factor, that's the length scale factor squared. Now if that means nothing to you, don't worry about it, just do it the way that I've said before. Again, in the Intermediate Maths Challenge, because people of lots of different age groups take it, there might be some theory that older students will know that younger students don't. I'm not going to go through that whole theory here, but basically it says that if if you've got similar shapes and all the lengths scale up by a certain scale factor, the areas scale up by that scale factor squared. Okay, so here in this example, the length scale factor is √2. I square that and I get 2, and that's the area scale factor, right? And you can see that's how these areas scale up here. 2 times 2 is 4, 4 times 2 is 8. So actually, if you're really sharp here, you might just spot that once the first area is 2, the next one is 4, and the next one is 8 without doing very much work, and get to that answer of 14 and save yourself a bit of time. That's the sort of thing that those students who are getting close to full marks in this paper and really pushing to qualify for the Olympiad might be doing. But again, just do it in whatever way you can. The key for the maths challenges is make as much progress as you can. Yes, use clever ways if you can, but actually just whatever method you spot, go with it, try and get the marks, and then move on to the next one as quickly as you can. So well done, however you did that, if you got it right. And interesting, I hope to see that there are many ways to solve a lot of these problems. So we want to find how many sets of 3 consecutive integers there are in which the sum of the 3 integers equals their product. Now, you might get a little way with trial and error here. You might find some answers, but the only way we're really going to be sure we've got them all when we've got them is to do this algebraically. So we're going to call the 3 integers n-1, n, and n+1. You could call them n plus 1 and n plus 2. This makes the algebra particularly neat. So the sum of these, when I add them together, you see when you use n-1 and n+1, adding them together, the -1 and the +1 cancel out, and then we've just got the 3 n's, and then the product is going to be the n-1 times n plus 1. So the sum equaling the product here means that 3n equals n-1 times n plus 1, and we've got a factor of n on each side here, and I'm going to divide through by n both sides of the equation here and get 3 equals n-1 times n plus 1. You've got to be careful when you divide through by something algebraic that thing isn't 0, and of course here n might be 0, and that is the first solution that we can find here, right? So when I divide by n, I need to say something like or n equals 0, and indeed that's the first one that works here, -1, 0 and +1. So I've got one set that works, and then I've got a difference of 2 squares on the right here, n squared minus 1, so that gives me n squared equals 4, and so that gives me 2 more possibilities, n equals 2 or -2. I'm doing it in this way, we can be absolutely sure that we've got the right answer, and we've got all of the answers, I mean. Of course, if you started with n plus 1 and n plus 2 instead, you might have something like, that's going to be equal to 3n plus 3 now, and actually we can do the same sort of thing here because you've got 3 times n plus 1 on this side, and you've got a factor of n plus 1 on the other side, so those would cancel, and then I'd be left with n plus 2 equals 3, which gives us n squared plus 2n minus 3 equals 0. We can factorize that as n plus 3 times n minus 1 equals 0, and again I get the first solution where I divided through by n plus 1. I need to say, okay, well actually n could be -1, and we get 2 solutions at the end here, or 2 roots, so n equals 1 or -3, and again here the values are all 1 lower than they were here because in this case they correspond to the first number, but here they correspond to the middle number. So either way it's fine, but you see, using that choice of n minus 1 and n plus 1 and n as the 3 numbers really does make the algebra quite a lot simpler. So in general, if we have consecutive integers, if you can center them on n, you can often save yourself a lot of time like that. So in this question we've got 3 numbers on the second row of this pyramid are all equal, so it makes sense to give them a name and to fill them in here. So let's just call them all n, and then we're told that the cell above each cell is the sum of the 2 below it. So like where I've got n and n here, there's going to be 2n above it, n and n here, there's 2n above it, and then if I fill in the ones above those, we've got 4n here. So if they're all integers, that means the top row here is 4n, and we get very quickly here that the answer is D, that it's a multiple of 4. Of course, there may be different choices for what goes underneath here, but one possibility would be that we had a half n, a half n, a half n, and a half n, and if we choose n to be an even number, then they could all be integers, and you can say pretty easily here then that you can find counterexamples for everything else, right? So maybe if you just make all of the bottom ones 1, and then all of these ones are 2, and all of these ones are 4, and all of these ones are 8, then bottom row doesn't contain a 0, third row doesn't contain a 0, the top number is not a multiple of 3, and none of the above doesn't apply because D is the answer, of course. So there we go, but you don't need to do that. In a maths challenge, once you've noticed it's D, you can move on very quickly and spend time on the other questions. So I've turned the grid lines on here, and of course you don't get squared paper in the IMC, but just for illustration here, I've drawn the 2 points, assuming every square is just 1 unit here, so this would be 1 and -1, and this one would be 5 and 3, and the line that will do this reflection to take 1 point onto the other here is the perpendicular bisector of the line. Because when I do a reflection in a line of a point, I take the closest point on the line, which is also from dropping a perpendicular to the line, and I go the same distance on the other side of that line. So what I'm looking for is exactly the perpendicular bisector. So that's what you kind of need to know for this question. Of course, now I've drawn it accurately, you can read off perhaps what the equation of the line is. But if we didn't have perhaps a really accurate picture, what I would want to do then is think about what's the midpoint of the points, right? So I've got the points 5, 3, and 1 minus 1. To get the midpoint, I take the average of the x coordinates, so 5 plus 1 over 2, and the average of the y coordinates, so that's 3 plus minus 1 over 2, and so that's the point 6 over 2, actually let's just write 3, and 2 over 2 is 1, so the line has to go through 3, 1. Now if you check this, yeah, 1 is equal to 3 minus 2, so that's okay. Actually y is 1, x is 3, and then this one has y equals 3, and this would also give 1. Sorry, no, this one wouldn't. If I put in x equals 3 here, I would get y equals minus 1 for this one, so that doesn't work. And if I put in x equals 3 to this one, I do get y equals 1. So it actually only rules out D. So we actually do need this perpendicular condition. So the gradient of the line that goes through 1 minus 1 and 5, 3, to work that out, we can do change in y over change in x. So 5 minus 1 over 3 minus minus 1, which is just 4 over 4, which is 1. Right, that's the gradient of this dotted line effectively, and to get the perpendicular line we take the negative reciprocal of this, which is just minus 1 over 1 here, which is minus 1. So there's a bit of theory here. Again, one of those questions that maybe disadvantages younger students slightly. Have a look at my other courses where I go through lots of the theory for this sort of thing. All of this stuff is in the Get Ready for A-Level course. And there's some stuff about straight lines and things in the Go for Gold ages 13 to 16 course as well. But the point here is that the perpendicular bisector has to have gradient minus 1, and now we can just see, well, okay, what are the gradients of these lines? If I just think about y equals mx plus c, the gradient of this one is 1, so it's not that one. This is a flat horizontal line. This one is a vertical line, so it's not either of those, and so it must be this one. And yes, the coefficient of x here is minus 1, so it's got gradient minus 1. So E is very much the answer there. So I really hope that was useful. Don't forget, I think the best way to prepare for the Intermediate Maths Challenge is to click below and take my totally free online course, Get Ready for the Intermediate Maths Challenge, where you can work through all of these problems and more, not just with the solutions, but also with video hints to help you get started. So do check that out if you haven't already, and share it with your friends. Please do like this video and subscribe to the channel as well. It really helps me get the content out there, and I will see you soon.